Hello and thanks for watching Gary Teaches Maths. This is the higher tier paper from June 2019 and it's paper 2. So question 1 is a question about inequalities. So given this inequality here, which is 14n is greater than 11n plus 6. So what we've got to try and do is treat it as though it's an equation and get the n on its own on the left hand side of this inequality. So what we could do is we can first of all collect up all the n's on the left hand side by taking away 11n from both sides, just like we would do if there was an equals in between. So we're going to take away 11n from both sides, and what that's going to mean is the n's are going to cancel on the right hand side of the inequality, and we're going to end up with 14n take away 11n, which is going to be 3n. So we've got 3n is greater than 6. And then all we need to do is get rid of the 3. So because that means 3 times n, what we would do is the opposite, and we would just divide both sides by 3. So if we do that, we do this, and we get rid of the 3 there, and we're just left with n on the left-hand side. We've got n is greater than 6 divided by 3 is 2. And that's it. We've done it. So that's part 1a. And for the second part, we've got a number line, and we've got a set of values for which it says x plus 3 is greater than minus 2, but is less than or equal to 4. So what we would do is try and solve this first of all by treating it as two separate inequalities. So if we take this part of it, the left-hand inequality there, we've got minus 2 is less than x plus 3. So what I'm going to do is just get the x on its own by taking away 3 there. So if I take away 3 both sides, I actually end up with minus 2 take away 3 actually goes further negative and becomes minus 5, and we're left with that is less than x. So the 3's cancel there, and we're left with minus 5 is less than x. That's one half of the inequality. So the other half is saying that x plus 3 is less than or equal to, because that's what that extra line represents, but also being possibly equal to 4. And now what I'm going to do is take away the 3. So I'm going to take away 3 on both sides, and we end up with x is now less than or equal to negative 3. Sorry, not negative 3. 4 take away 3 being 1. There we go. So I'm going to recombine these two now with the x in the middle, and we've got x is greater than negative 5, but also x is less than or equal to 1. So we've solved the inequality now, but we need to represent it on this number line. So we can see that x can be between minus 5 and 1. But actually, because it says it's greater than minus 5, it means it can't be equal to minus 5. And the way we represent that is we do a circle, but we don't colour it in. And at the other end, we are saying that x can actually be equal to 1, although it's less than as well. So represent that there, and then we just join them up. And that's it. That's that range represented by this inequality shown on the number line. So it says, just to reiterate, it says that a circle with that's not coloured in is not equal to, like that one. But if it's got the equals to bit as well, then we actually colour in the circle to show that it could as well be equal to 1, as well as all the values less than it. And that's it. So I hope that's been helpful to you. If it has, please like our channel, which is Gary Teaches Maths, and subscribe to our channel and like our video. And also, for more help, see our website, which is bestmathstutors.co.uk, and is just appearing here at the top left of the screen. Thanks for watching.